log of e to the x is equal to x. Yes?
Yeah.
We just did this, right?
Oh, yeah.
Okay, so we're going to take the derivative of both sides with respect to x. So okay, all I did was write out, we're going to do the derivative of each side. So what's the derivative of a natural log function? 1 over the stuff inside, right? So we're going to get 1 over the stuff inside, which is e to the x, times the derivative of that stuff inside, right? That's u primed, essentially. So times the derivative of e to the x. Does that make sense to everybody? That's just the natural log derivative, u primed over u. What's the derivative of x with respect to x? Just 1, right? Yeah?
Yeah.
Okay. So now I'm going to multiply this e to the x up to the other side. Have I done anything that makes no sense?
I mean, why did you do it? But
You'll see why in a sec here. But nothing I've done has been like out of bounds mathematically,
no.
right? Okay, what does the statement say? The last statement, this bit. What does that say? The derivative of e to the x is e to the x.
So we just solved if it's right or wrong. Right? We were just trying to figure out if the.
No, I'm just trying to figure out the derivative of e to the x, and it is e to the x.
Yeah.
Okay, how's that possible?
I just showed you.
No, but like that.
I didn't do any. Did I do any magic?
No.
I did nothing.
Why is it?
I wrote out a true statement. Yeah. I took the derivative of both sides. The derivative of a log function is 1 over this thing times the derivative of that thing. Well, I don't know what the derivative of that thing is, so I just wrote d dx of e to the x. The derivative of x with respect to x is 1, and then I multiplied this e to the x up, and I got the derivative of e to the x is e to the x. It is itself.
But why? Okay, algebra makes sense.
Granted it's a little strange, but it is. It is. All right. So, if I asked you the derivative of e to the u, what would that be? Close. It'd be e to the u times what? Times u prime, the derivative of whatever that thing is. You have to use chain rule, right? I'll say du dx, but really it's just e to the u times u prime, whatever the derivative of the exponent is. That's it. The derivative of e to the x or e to the anything is straightforward. It's just that thing times the derivative of the exponent.
Oh, so the derivative
Sorry.
of x is just 1?
Yes.
Is that,
That's
that
what I-
makes sense.
But actually, it
Okay,
makes
that
sense
makes
why
sense.
EDX is
Yeah, that makes sense.
right. But it still doesn't make sense.
So wait,
It's
why
weird.
would
I get
it
that. Like I understand that. But
So
there it
U
is.
here not like x?
sorry?
Is u here not?
Yeah, it's not x. It could be. You'll see. It could be anything. It could be a trig function if you want it to be. You don't want it to be? So if I say, what is the derivative of e to the x squared?
EX times, no, EX squared is 2x.
2x.
There you go.
2x.
2x times e to the x squared. It's just itself
Okay.
times the derivative of the exponent. Is that okay? All right. Let's do. Come on. There we go.
We're done with this.
Yeah,
This was a bonus question.
Now we can do fun curves to sketch.
Oh, we're gonna curve sketch now?
Not today, but we will.
Why do you have to bring something so awful back?
Find the relative extrema. So I just got to find the maxes and mins of x e to the x. How do you find the extrema? Yeah, so you take the first derivative, set it equal to 0. So what rule do we have to use for this? The what? Product rule. Product. You're going to write a final exam where all this is on it, right? So the derivative of this is, product rule says, derivative of the first one. What's the derivative of x? Times the other one. Plus the derivative of the other one. What's the derivative of e to the x? Times 1 times the other function, which is x. Okay. We set this equal to 0, correct? Can I factor anything out? What can I take out? E to the x can come out. You get 1 plus x. Huh? Yeah, so will e to the x ever be 0? No, it can't be 0. Therefore, x is equal to -1. That's your only critical number. So we want to test and see if this is a max or a min. So we'll do the, so -1 is there. You test the intervals. So let's test to the left. What would be a nice number to pick for the left, to the left side of -1? -2. If I put -2 into here, what's 1 plus -2? -1, right? If I put -2 on E, is that positive or negative? e to the negative 2. If I say e to the negative 2, what does that actually mean? It's positive because it's 1 over e squared, right? So this is always positive. And if I put negative 2 in there, that's negative. So that means we are going down.
A negative exponent is just the reciprocal of the exponent, just one over whatever.
Negative exponent just means 1 over, right? And then if I pick, what's the easiest number to the right of negative 1? Vina? 0. If you put 0 in, you get 1 in there. E to the 0 is? So it's positive, which means we're increasing. Therefore, we have a min at x equals negative 1. What's the y value?
We plug in negative one.
To where?
The original function.
To the original function. So you'd get negative 1 e to the negative 1. So the coordinates of your minimum are negative 1 and negative e to the negative 1, or negative 1 over e if you want. So that's a min. Do we like that? Why is it decreasing? Because you have a negative number when you put in like negative 2. Yeah, this part, right? I put a negative 2 there, but if I put negative 2 into here, I get 1 minus 2, which is negative. So, all right, here's your practice questions before we do the integration. 352, 33 to 53 odd. Yeah, we'll stop there. Essentially. All right. What is the equation of the tangent line of f of x is equal to e to the negative x times the natural log of x at 1 and 0? Okay. As soon as I say tangent line, you have to take the derivative. So f prime of x. What rule do we need to use here? Product rule. What's the derivative of e to the negative x? Negative, yeah, times negative 1. So negative e to the negative x times the natural log of x plus, what's the derivative of the natural log of x? 1 over x times the other function, which is e to the negative x. Okay. There's our derivative. Yes? Okay. We need to know the slope at 1, 0. So what do? Put 1 into the equation. Well, there's no y's, but yeah. If it was implicit, you'd put y's in. So you get negative e to the negative 1 natural log of 1 plus 1 over 1 e to the negative 1. Why is this nice?
What do we do there?
Does anything disappear?
Put 1 in as x.
Oh my gosh, people. Say it.
It disappears.
Why?
Because he's going to equal negative 1, and then when you multiply, never mind.
LM1 equals 0.
Yes, the natural log of 1 is 0. I thought you were going there. So the natural log of 1 is 0. So that whole side disappears. So you're left with e to the negative 1 or 1 over e, right? That's your slope. It's a beautiful slope, 1 over e. All right, then we go, okay, mx plus b, or you can use point slope equation. Do you remember those? It doesn't matter which one you use. I'll do both. So, if I'm going to use mx plus b, I plug in my x, my y, and my slope. So I get 0 is equal to m, which is 1 over e, times x, which is 1 plus b. Therefore, b is equal to negative 1 over e. So the equation is y equals m, 1 over e, x minus 1 over e. Beautiful. Look at that. That's pretty neat. No. Everybody's just like, yeah, whatever. If you use the other one, your x and your y go in. So you get y minus 0 is equal to m x minus 1, which gives me same thing. That is the equation of the tangent line. At what point? Here? Because I'm asking for the tangent line at the point 1, 0. So the derivative gives you the slope at every point. At the point 1, 0, I plug in 1. This goes away, so I'm just left with this. So that's my slope. And then we write it mx plus b, or this one, doesn't matter. I plug in my m and my x and y, solve for b. Yeah. All right. So your questions are 55, 57, and 61 on the same page, 352. And that will bring us up to the end of the day.